All right, we're going to look at one more word problem here. So a city decides to make a park by fencing off a section of the riverfront property. Funds are allotted for 80 meters of fencing. The area will be enclosed will be a rectangle, but only 3 sides will need fencing because the other side is going to be bounded by the river. What is the maximum area that can be enclosed? All right, so we have a picture here. So this is one side of what we're fencing off is going to use the river, so we don't need fencing for that. But we do need fencing for these 3 sides. And I've gone ahead and labeled them. This side is H and this side is B. You can certainly label them however you want. And what we're going to do is we're going to come up with 2 formulas here. So we're going to look at a formula for figuring out what's going on with the fence. And then we'll do a formula for the area. Okay? And especially because the area is what we are looking to maximize. So that's the formula we're going to be working with primarily. And the area is the base times the height. Okay, so that's not too bad. And then let's look at what we know about the fencing. So we know that we have 80 meters of fencing we can use to construct these 3 sides. So I can write that as 2H, 1H, 2H plus a B is equal to 80. Hopefully that makes sense. This is kind of a modified perimeter here since we don't have, it's not completely enclosed all by fencing. But that's essentially what we're looking at doing here. And since I know that this is what I want to maximize, I'm going to solve this formula for either B or H and plug it in here. So this is just in one variable. So I'm going to solve for B. It doesn't matter which one you solve for, but that just looks easiest. So I have 80 minus 2H. And then I'm just going to replace that over here. So A is equal to 80 minus 2H times H, which gives me 80H minus 2H squared. Okay, and there we go. That is a quadratic function. And you notice in front of the H squared that this is a -2. So our A is less than 0, which means this is going to open down and we'll get that concave down shape, which means we'll be getting a max out of this. All right, what I want to do is I'm going to graph this in Desmos and I'll get the vertex out of there, and then I should be able to answer this question. All right, so here I put in our function 80x minus 2x squared. And if I head up here to where the vertex appears to be, I get a vertex of, let's see, h is equal to 20. So if the height is 20, the area will be 800. Okay, and let's switch back and we'll finish writing our answer up here. All right, so I wrote down the vertex we got from there. So this says if h is 20, so we know our h, then our max area is 800 meters squared, since we are in meters here. And then just for fun, we can actually figure out what this side length is too, which I think might be surprising. So that's B is equal to 80 minus 2 times 20. So 80 minus 40. So this side needs to be 40 meters long. So I need 40 meters by 20 meters in order to get this 800 meter area. All right.